Hi guys, Arthur here with O+P Digital Designer. Today I wanted to answer a quick question that I've been getting a lot of queries about. It's how to take a 3D scan from a 3D scanner in O+P and get it into a CAD package in the way that you can use it for your reverse engineering or CAD product design. It's easy enough to do, and today we're going to be using Fusion 360 as a CAD package as well as Zbrush to modify our mesh. So starting off here, if I open up the raw mesh that was scanned using Comb Scan, an O+P iPhone scanner, you can see that it comes in misaligned, it comes in at a really high density, and it comes in uncleaned. This is a very hard thing to try and position and use or correct inside of a CAD package. So it's not necessarily usable, but we want to get a usable file of this type into CAD so that we can align it and then work around it in parametric design. So this is a common problem that many people face. So let's dive in and use a ZBrush workflow to get that result here ready to go and scaled. Starting off, when we open up ZBrush, you're going to see a menu that looks very similar to this. I'm going to exit out of this and hit the hide on the lightbox mode here so we get a blank screen. If you guys are interested in this workflow or know how to use ZBrush, feel free to follow along. If not, I have a custom menu set here that was built specifically for this workflow. If you message me or schedule a meeting through opdigitaldesigner.com, I'd be happy to share this menu with you or talk about different workflows that also do this much easier. So starting off, how to use ZBrush very quickly is we're going to start off by just importing our file. So I'm going to use the import OBJ button on the right here and bring in a scan that was done using this comb scanner. I'm going to make sure I have a white material selected. And if I click and drag on the screen, you're going to notice that the scan comes in on the screen. So we don't want to click and drag many times because it's not going to allow us to edit. So we actually have to hit Control N for a new canvas and drag it on screen and then hit edit. Once we hit edit, we are able to fly around and look at this model in color as well. If you don't like the shape or the size, because this view is not to full scale, you can use the range in the document settings and a new document to size, and then click and drag one more time, hit edit, and now we're working in a full view space. So starting off, how would I work around this? Let's move my head here a little bit and hit the line view so we can see how much geometry we're working with. First thing let's align this so that it's corresponding to our XYZ. If I shift and hold down shift and drag, I want this to align so top, bottom are very clearly noticeable. So how we can do that very easily is hitting the W key to bring up our move tool. But instead of using this one, if we turn off the gizmo, we have the traditional gizmo that we used to be in the older forms of ZBrush. I find this one to be super useful because with a few simple clicks, we can click and drag, hit R on our keyboard to rotate, and then we can drag and hold shift so that it aligns upright. So I'm going to do the same thing here. Drag off the model, that's going to be important, and align it here. So now I can hold on shift, look at it this way. It's not quite aligned, so if I hold on shift and go to the top, I can hold here, hit R again on my keyboard, and align. It's not, probably something like that might be a little better. So you can see now if I hold on shift, a lot of this is in the right spot. And that looks pretty good to me. So hitting Q to return to our edit mode, we now have an aligned scan. What else can we do to this scan? Well, we can cut out the stuff we don't want because all of this extra noise from the prop that was used to scan this is still in the way. So in our next section here, we are able to, actually, no, I'm going to use the control. If you hold down Control and Shift, you're going to get different selection tools to be able to cut away material. So I'm going to use the lasso tool in the Control Shift setting, which allows me to drag this. Now I want to keep what I'm not selecting. So to invert this selection, I got to hold Alt as well to remove what I'm selecting. So I'm going to use Control Shift, drag, and then at the very end hit Alt and remove it. And then one more time here, Control Shift, drag, and Alt to remove it. It's about as good as I'm going to get here. I don't think I'm going to be able to cut this out much better. I can Control Shift, drag, hold down Alt, remove. If that hole is giving you grief in terms of where to look, you can actually turn on double, which will turn on double walled viewing. So once that's done, we can hit the delete hidden button in our geometry tab, which would otherwise be inside geometry. I've parked it here for easy use. So that's scan 1. We need to bring in another scan, though, in order to correctly modify the foot so that it's weight bearing. A great tip for doing scan work is to have one weight bearing and one non-weight bearing scan done up for being able to consolidate the two together. So I'm going to do that by duplicating this subtool. So we got 2 of them now. And in this new subtool, we're going to re-import the next mesh. And there it is. So we got a new mesh on top of our old mesh. This one you can see is weight bearing. So I'm going to now do the same process here. Hold down Shift, hit this eye so I can only see just one. And I'm going to go through the same process. So using my move tool, the traditional gizmo, I'm going to go through and I'm going to start rotating this so that my right foot in this scan is aligned to our origin. 1, 2, and then, drag, and 3. And because this has a very clear flat plane, maybe I can drag the gizmo here and get that nice and aligned. So compared to other CAD packages, this is a really great way to align a mesh. Not many other gizmos that I've been able to use in other softwares can do it this quickly and this intuitively. So bringing back our other one, I can see here that I didn't align it quite to the right size, so I'm going to make sure I do that. And now that it's more or less aligned, let's isolate what we want to keep. So holding down Control Shift, I'm going to change this to the rectangular lasso and use my rectangular selection tool this time to just keep what I want to keep and delete hidden. And a cool trick to continue to remove material here is to use the Auto Groups button, which will group islands of mesh together, which means we can now hold Control Shift and then select our group that we want to keep, and then everything else gets hidden, which we can then delete some more. And then finally, because this is on a nice flat plane, I can use my Control Shift again, hold down Alt, and just remove that final bit of material from the bottom. So we got a nice flat scan. Delete hidden once more. And there is our final weight-bearing scan of this patient. Now let's try and consolidate these two together. So I'm going to use the new modern gizmo, hold down Alt, and place it center, and reset my orientation so it's nice and flat. And then I can go and I can take these and I can line these guys up. Turn on transparency or ghost, which really does help as well. And so now what I'm looking to do is I'm looking for common landmarks in mostly the ankle area to line these two guys up, because there is going to be difference in the angle of the leg and the calf, and the foot as well. It also needs to be consolidated. So now that we've got something like this, we need to consolidate them to make a complete final scan. So I like how straight up and down this scan is, so I'm going to actually select this guy and go back to this scan, and now let's modify this scan to correspond with the one being ghosted. So I'm going to remove some of this material because I don't necessarily need that. Delete hidden. And now this scan, let's talk about alphas, because I can modify and move just pieces of this by masking away parts that I don't need. And a great mask to have is like gradients, because then we get these nice smooth transitions when I go to select. So I'll show you what I mean by that. If I hold down Control, this brush alpha now has that mask applied to it. So if I drag it out, my area of influence is in white, and anything in black will not be influenced. So if I want to do something like this is the area of influence I want to sort of gradiate over for this one. And then I can turn off that mask and then do the final selection here, just to make it completely stable on the bottom. So now with this masked away, I can again return to my gizmo by hitting W, rotate, and so it's back to XYZ, place it in a position in the leg that is conducive to rotation, and then now we just rotate this into place. 1, 2, 3, 1, 2. Nice and easy. Now that that's been corrected, we got to now modify the foot itself. So I'm going to Control Z actually, because I could invert this mask now, keep the calf in place, and now move the foot. So again, reset my gizmo, take it to center. I probably want to put it around here and then just do a slight rotation to get that sort of in place. And maybe the toes need to be lowered or reduced a bit as well. So I can select this, and holding down Control, I can really feather this by clicking many, many times. Invert that mask, bring this over, and drop these toes down. So they are more or less in line with what we're looking for. There we go. So now the foot itself, I think this foot is in a better alignment than the ghosted one. So this ghosted one, I wonder, can I move that just slightly to be more in line? You're going to notice a bit of width variation when it comes to a weight bearing scan. That's typically pretty normal. So I think that's about good. Where was it before? So yeah, so I'm actually going to gizmo myself over here, do a rotation from here, and just line that up a bit better. So far, so good. Final step now is to take that sole and to squish it down to the weight bearing scan. I'm going to do that by holding down Control and dragging my mask. So I'm masking away the sole of this scan, and then holding down Control, clicking on the model a bunch of times to feather the selection so it's nice and smooth. And then I can hold down Control, click off the model to invert the selection, hit W on my keyboard, hold down Alt and reset my gizmo, and then drag it to the line, the ground line of our weight bearing scan. Using my one-dimensional scale now, we can scale this down so it now has that sole. So if I turn off this and ghost and this one, unmask it, you can see if I remove color as well, now we have a consolidated scan between the two of them that has a lot of shared geometry. There's not a lot of deviation, and you also get sort of the foot as well. For any final modification, I might take this foot, mask away, blend it with my Control, and then I might actually try and expand this a bit just so that it's a bit more in line with, the weight bearing side of things. There we go. Between these two scans, we now have a consolidated, corrected foot ready to be used for a CAD package. The problem with CAD now is that although we've aligned it, this poly count at 75,000 or 140,000 points between the two of them is just too much for a CAD platform. We really don't need that kind of geometry. So finally, now that we've corrected it, we now need to go and reduce the mesh. So if we use the, let's combine these by going to merge and merge down. We're going to merge these into one file, and then we're going to process this file. And it's going to take a second to think about how many triangles it is. And because it's 136,000 polygons, I want to bring it down to about 60, which is about 20%. So if I hit decimate now, not a lot has changed on screen, but if you go back to that line view, you can see how many triangles are left. There's like next to none compared to what we had before. So this now would be fully finished, corrected scan ready to be used inside of a CAD package. We got to make sure our scale is corrected, so let's make sure we go in and update our size ratios. This definitely looks like a regular size scan. It's either going to be correct or it's going to be very, very incorrect. So don't worry if it's like, as long as it looks like it's a correct scale. I'm in millimeters right now. And so now that this is done, my scale check's been done, I'm going to export as an STL onto just the desktop here, save. And now with our corrected mesh, let's go back into Fusion and let's bring it in and see what happens. Nice. So it's now relating to our axis, which is great because if I want to go and now move this, I can just snap it to 90, snap it to 90, and I don't have to worry about anything. My origin is where exactly? Let's go bring it to center and let's move it to ground. And now you can see how it was flying off in space over there, but it's been brought to ground. It's at our origin point. I'm going to bring this into a usable relationship with the origin. I usually put the origin for scans in the heel, right in the center of the radius of the heel, something like this. I hit OK. And now inside of Fusion, we have a very small, low taxing mesh that's been aligned and scaled and ready for use inside of a CAD package for your development. So that's my quick tip. That's my workflow for getting scans into Fusion 360. If you have any questions or are interested in learning more about this, feel free to contact me and send me a message, and I'd be happy to answer any more questions you have.